My name is Alroy Almeida. The folks here at TechWaterloo invited us out to talk about our story. So it's not going to be a presentation about a specific topic, but on us, our technology, very selfish stuff like that. So, and that's, our story is actually, it's a story of building the impossible, buying one-way tickets to China, getting jumped in Vegas after winning $50,000, becoming one of the top 10 Kickstarters of all time, and now finally making sure the products of the future are built faster than ever before. Now, you must be reading that and be like, okay, this guy's got a couple stories and he obviously helps people build electronics. So why in the hell is he wearing a shirt that says building hardware sucks? Well, that's because building hardware sucks. All right, so a little background about me. My background is in industrial electronics, General Electric, Schneider Electric, Siemens. My business partners come from robotics, automation, electronics backgrounds. And no matter what company we worked at, we kept running into the same problem. And that was that we would design circuit boards, the little green boards that go into every electronic device ever that actually make them work. We would design those, send them to factories over in China, spend hundreds and hundreds of dollars, wait for weeks and weeks and weeks, and we'd get them back, and they'd be wrong. And so we do that over and over and over again until we were past our deadlines, over budget, and I'm getting called into the boss's office explaining what the hell just happened. So we decided that something better has to exist out there. So we started looking, and there wasn't. And a few of us got together. We started talking about 3D printers, and there's this great tool for prototyping mechanical objects. Or our mechanical engineering friends had this fantastic tool to work with. And software development, don't get me started on software developers. You guys just hit compile, milliseconds later, your code is there. Meanwhile, we're sitting here twiddling our thumbs waiting for the FedEx truck. Just not fair. So we created the Voltera V1. Front row gets to see it over here. Everybody else sees it up there. So the Voltera V1 is a printer that sits right on your desk and can print out those circuit boards in the matter of minutes, rather than sending it out to China and spending weeks and weeks and weeks waiting for it. Now, for all the manufacturing and electronics nerds in the room, we print the boards. We also dispense solder paste. We also reflow the boards. That addresses all two of you here. All right, so I'm also now going to break the cardinal rule of giving a presentation, and that is doing a live demo. Once again, only for the first row. Everybody else, I'm sorry. All right, so, and literally just hit print. All right, so let's see if we can print an entire circuit board in the time it takes for me to give this presentation. So it's starting over there. All right, so we are the hack of the month, so let's talk about hacking. This was the first electronic thing ever that we made. Happened 4 years ago probably like tomorrow or the day after is the 4-year anniversary of this. It's a little LED. You can see that the electronic traces are actually arrows because we made that in Microsoft Word because that was the only thing we could print from. And that was a little LED that we turned on. And I shit you not, we turned that LED on and we started jumping around the room because knowing what we know now, back then, but knowing what we know now, that's not possible. In fact, when we, after doing that, we started talking to electronics experts, because what we're printing there is a silver nanoparticle material, silver nanoparticle conductive ink. And on the material side of things, we didn't know what we didn't know. And so that's when we brought our fourth co-founder on because she's got a background in nanoparticle development. And we started talking to these conductive ink experts, electronics experts, and they told us, kids, go get a real job. This is impossible. Don't waste your time. And I think this because we were young and stupid and had some time to kill. We said, we're gonna try this. We're gonna build this. And fortunately, we had that nanotechnology expert. My other two co-founders are two of the smartest people I've ever met in my life. And just with that and thinking a little bit outside the box, we printed our, we got to this. But it didn't always look like this. At one point it looked like that, which was a monstrosity of a product that was what we went to China with because we got accepted into this manufacturing program over there. And within a week, we had basically bought flights, visas, and vaccinations got on a plane, and moved to China to basically learn about manufacturing. The entire company was there for 4 months, and then for the subsequent 2 years, we had at least one person, usually two, on the ground over there. And then that's what we came back from China with. China's amazing. If you want to talk about like conductive inks and stuff, I'll talk to you about that. If you want to talk about manufacturing, I could talk to you about that as well. So basically, we got back from China with this thing that kind of resembled a product, which was nice. This was probably about 2 years in. And we decided to launch a product. So we launched a Kickstarter campaign. Yeah, this was about 2 years ago now. One of the highest fundraising Kickstarter campaigns of all time. We delivered our early bird units on time. We don't talk about the rest of the band, but we delivered our early bird units on time. And then, you know, a bunch of stuff happened. You know, Kickstarter named as one of the top campaigns ever. That's like Pebble, Oculus, a guy that built a human-powered plane, us. And then we won TechCrunch Battlefield, TechCrunch Disrupt in Vegas when the jumping thing happened. Popular Science Invention of the Year. We were the first Canadian company ever to win the James Dyson Design Award, so you know, represent Waterloo, represent Canada. But yeah, that's all great for making my mother proud. But let's talk about what's actually important, and that is customers. So you know, we have some customers who are hobbyists that are building little projects in their basement. We've got a lot of academic institutions using it as a teaching tool, as a research tool, but primarily we sell to businesses, right from tiny startups like ourselves to giant multinational companies that are getting that edge, trying to get new products into market faster, trying to develop a lot faster than ever before. And you know, some of the stuff that we've been printing from them, you know, antennas and filters, RF stuff, all the way up to one of the guys at our office actually printed a Nintendo NES controller on glass, because you know, you can now. Yeah, that's kind of what that was. I added another slide, but it's not here. But basically, that's where we are right now. We've got hundreds of units in 40, 50 countries around the world. Basically helping people get new products out there faster than ever before. And yeah, I'm taking questions now. One thing I should mention, because I mentioned this to a customer yesterday and like blew his mind. Yeah, we had some experience in China, but the majority of the custom manufacturing is all done here in Ontario. We build everything in-house and ship it out directly to our customers. Hopefully that's scalable. We'll see. Yeah, we're hiring on sales side, manufacturing side. Company is finally at a stage where you know, things are going well. So yeah, questions? What's up?
So you mentioned you were talking to professionals, and they were saying, you know, just go get a job or something. It's impossible. And you decided to go against those recommendations. What makes it possible for you? So what made you decide to go down that path as opposed to actually taking advice, or how do you distinguish between taking advice and at face value versus taking advice with a grain of salt?
You're speaking specifically to how people told us that it was impossible. Okay. We had, like I said, we had turned that LED on before any of that happened. So we're like, okay, no, this is obviously doable. But when we went to them, we were going to them because we said, all right, this is our spec for conductivity. This is our spec for solderability, for resolution, all these different things. And that's what they told us was impossible. And at that point, we're like, okay, like we proved that, you know, ink from a printer can turn an LED on. It can make circuit boards. We know it can. We're going to give it a year. 2 years later, we finally figured it out. But yeah, it was just that little bit of hope that we had, that kernel that you know, we'd already proven it. Why don't we just pursue this a little bit more? And you know, we spent the first 10 months on the completely wrong technology. You know, that first LED we turned on was, we went to Staples, we bought a Epson printer, we took it to the machine shop, ran it through a bandsaw, took out the ink, put a, you know, conductive ink in, and that's what that was. So it was completely inkjet based. And when we were talking to people in the industry, That's what we were talking to them about. We're like, oh yeah, we've got this inkjet printer. And they were like, no, that won't work. It was us thinking outside the box, like I said before. It's like, okay, well, if inkjet won't work, what about other things? And that's when we started getting into like the darker regions of conductive ink, where there was less research going on, because inkjet was the hot new thing. Conductive inks have been around for 10, 15 years now, maybe more now that we've been at this for 4 years. And people were trying to get them commercialized, but it wasn't happening. And now we've built this tool that kind of took out the initial assumptions. And we're like, okay, well, everybody's thinking about it this way, let's think about it in a different way. And now we've built this tool that, sure, you can print conductive inks, but we've also printed adhesives and a whole bunch of other materials for people. Like I showed there, we've got circuits on standard FR4 fiberglass, but we also got them on flexible materials, glass. I've got a business card that I printed over there this morning on carbon fiber. So yeah, I mean, we're electronics company, but manufacturing company really, and trying to help people use additive technologies to do that. And it's a really new space, so it requires people to just keep screwing around and seeing what happens.
So over here, how do you? I'm not a hardware guy, so forgive me. How do you estimate things like longevity? Because you've got like the try, test, and true product, and you're coming up with this really cool, innovative thing. But if every board stops working 2 years down the road, that's kind of a problem. So how do you estimate something like that?
Yeah. First of all, we are not a long-term solution for your electronics needs. Those factories that we have, I was attacking slightly, they are great at what they do good, which is mass manufacturing. They are not good at low volume. We're fantastic at low volume. We suck at high volume. So it's kind of that relationship where we can kind of help each other out. That being said, we wanted to see how, what our performance was like long term. And so for, I think, the majority of last year, our engineers basically had a circuit board that they had on constant load for months and months and months and months with no degradation. We've got research projects with a whole bunch of universities across Canada that are testing out different things about our materials. So that's on the longevity side, high speed, high power, RF, a whole bunch of things. And so we're basically working with people and doing our own testing in-house to see what sort of applications we can actually hit. Because, yeah, I mean, conductive ink, not the same as standard copper. We're not going to pretend like it is. We are very, very clear about what our limitations are. But for the people we can help them a lot.
We're going to have to move on just for time, but if you're around at the end, we can do.
Yeah, I'm right over there. I'll keep printing, or come talk to me about electronics, manufacturing, anything else you want to talk to me about the Hamilton soundtrack. Come, whatever. Let's chat. All right.
Thanks,